So we're going to be graphing square root functions, and this is going to be very similar to a quadratic. Remember, a quadratic was one that had that u that went up or down, but we're only going to have half of it, and it's going to be turned on its side, like this, like this. Oops, no arrow on that end. Or it could go backwards. It can go back to the left. So it's only going to be half of it, and it's only going to be a portion. And so let's talk about how the transformations. And the vertex is always that we're talking about transforming, is that starting point of that curve. That would be like the highest point over the parabola. But on a square root function, it's going to be where the curve starts. And so A is going to do the same thing it did last time. If A is between 0 and 1, then it's going to have a wide curve. And if A is greater than 1, it's going to have a sharp curve. So that's what the A is going to do. But A also is going to tell us, and there's a vertical reflection. That means it is reflected across the x-axis. So those would be the ones that are upside down. H and K are going to work the same way they did last time. H is going to tell you if you went left or right and how much. And remember, it works opposite on this. So if it's a minus, you're going to go right. And if it's a negative, it's going to go left. Excuse me. It's a negative. If it's a minus, you can go right. And if it's a positive, you can go left. The K tells you you're up and down. And this is going to work the same. Signs are going to work the same as normal. One method for graphing is you take and plot your HK. And then you just calculate ordered pairs. And do a table. We're going to do a different method. We're going to use that same thing that we did last time, that 1, 3, 5 pattern. But this time, this is our move on the x-axis. And then again, we're going to connect with a smooth curve. This is one of I told you there's going to be a few times where we have a special case with our domain, where it's not all reals. These are those guys. These guys are not going to have a domain of all reals. So pay attention to that. The domain is not going to be all reals on these functions. So let's look at the first couple. So let's start off with graphing the parent function, which is this y equals the square root of x. The parent function is going to start off with the origin. And we're going to follow that 1, 3, 5 pattern. This is, again, the x movement. And so the y is always going to step up or down 1. So we're going to step up 1, go over 1. Step up 1, go out over 3. Step up 1, go over 5. And then you're going to connect it with a smooth curve. The arrow is going to go on the side away from the vertex. Now, let's look at graphing the transformation. And we are going to identify where is our vertex. That's the first step. And our vertex is going to be at our h value is 0. Our k value is 5. And it was positive, so a 0, 5 is where we're going to start. So 0, 1, 2, 3, 4, 5. So our transformation is we went up how much? And if you look at the rest, there is nothing in our A spots. That's an A of 1. So that means it's going to follow the same pattern. So let's go ahead and graph this. Up 1, over to the right 5, over 1, up 1, over 3, and up 1 over 5. So all we've done is pick this graph up and move it above the same, and then the transformations are going to be the same. So domain, what x values did we go through? Well, we started here. There was nothing to anything left of that. So our domain starts at 0. This arrow tells us we go on forever, so that's positive infinity. Our range, our lowest y value, we start at 0, or not 0, at 5. And we go up to positive infinity. So left to right for domain, down up for range. Now let's do another one. I have already graphed the parent function. If you want to keep graphing it on yours each time, you can. If not, just go ahead and move on to transformations. And so if you want to do your transformations, that you can mark out this x, y, and do your 1, 3, 5 pattern. So in this case, we have our h and our k. So our h, there's nothing inside here with this. That means there's 0. Our k comes from the outside. So 0, 3 is our vertex. So at 0, 3, I'm going to put a dot. And then we're going to look at that pattern, that 1, 3, 5 pattern. And this time, we are going to, because of our a, multiply those times 2. So we have 2, 6, 10. Obviously, we're probably not going to get all those graphed. So let's follow the pattern. Again, these are going to be your x changes. These are your x values that you're going to be moving. Your y values is going to be a step up of 1 if it's positive and down of 1 if the a is negative. So up 1 over 2. And put the dot. Up 1 over 6. And put the dot. And connect with a smooth curve. So what happened this time? Well, we had a transformation of up 3, and we also had a stretch on our graph by a factor of 2. Our domain, we want to look at our x values. What was the farthest value to the left? 0. What's the farthest value to the right? Infinity. Lowest value for range, well, this one has a starting value at 3 and goes up to positive infinity. Let's look at the next one. First, we're going to identify our h and our k, and this time we actually have an h. But remember, we go opposite of the 2, so it's going to be a positive 2, negative 1. So positive 2, negative 1, push that dot to start here. Undo. Now, we need to take and look and see, what does that pattern 1, 3, 5, do we have anything in A that's going to change that? And no. So we're going to go up 1, to the right 1, up 1, to the right 3, up 1, to the right 5, and well, that puts us off the graph, so we can't graph that point. So graph the ones we have, put an arrow at the end. And so this one, we went right, 2, up, down, 1, and that was the only transformations. We did not have any stretches or compressions on this one. So let's identify our domain and range. Domain, Where was the farthest to the left we went? Well, it was here. That's at positive 2. What is the farthest to the right? Well, that's the arrow, so that's infinity. And then our range was our lowest value. And that would be here, so that's going to be -1. Our highest value is infinity. Let's look at the next one. This time there's a negative value in that A spot. So that means instead of going up, we're going to be going down. So instead of going up 1 each time, we're going to be going down 1 each time when we plot our points to move on. So let's first identify our HK. Your H is opposite of this, so that's going to be +1. Our K is +4, because it's going to be the same. So +1, +4, 1, 2, 3, 4. And then our transformations with our A. And so we're going to work with the pattern of 1, 3, 5. And our A is a -1, which is just meaning that it's going to stay the same. And so I'm going to go down 1, and I'm going to go right 1, down 1, right 3, down 1, right 5. And then connect it with a smooth curve. So this one's a little bit different. All the other ones have been going up, and so therefore our range was always going up. But this time our range is going to be set up you don't have a lowest point. So our lowest point is going to be -infinity. And our highest point is going to be this value. So that value was at +4. Our domain, we started at 1, and we keep going to the right. So therefore we start with a 1, and we go to the +infinity. Our transformations. What were our transformations? Well, we first have the H and a K transformation. So we went right 1, we went up 4, but we also have the transformation for the A, which is a reflection across the X axis. One more, and I know this is not in your paper, but go ahead and sketch this one out. We have the same parent function, but we have another reflection. And so let's go ahead and go back to the front page. I realize I didn't give you this example. If under your square root, you have a negative value, this is going to tell you that there is a reflection across the Y axis. That's how we get it to go back to the left instead of go to the right. So let's go back to the problem. So instead of going towards the right on this graph, we're actually going to go to the left. So we find our vertex the same way. Opposite, but this has to be factored out for us to work with it. So if it's not factored out, you have to factor it out. So opposite of that, 7 is going to be, or opposite of the -7 is going to be 7. Our K is -2. So I'm going to go right 7, 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 2. Puts my dot here. And okay, there is no compression or stretch in front. So we're going to follow that pattern 1, 3, 5, but this time we're going to be going back to the left each time. So we're going to go up 1, left 1, up 1, left 3, up 1, left 5. And then connect that graph with a smooth curve. So we had right 7, down 2, and we were reflected across the y-axis. And so let's identify our domain and range. How is it going to be different this time? Well, our domain, the farthest to the left, is where that arrow is. So that's going to be an infinity. So negative infinity, comma. Where is my farthest to my right? And that's that point, which is at 7. Your range. We're going up, so we want to look at the farthest down, which is negative 2. And we're going to the farthest up, which is positive infinity. Tonight's homework, all you're going to be doing is working on the transformations. You're going to tell me in your verbal transformations, identify those. We will start building in, and on Wednesday you'll actually graph these functions.